This is an old Amstrad 8000 Mark II. It's one of Amstrad's first amplifiers they made back in the 70s. It's quite a cool looking unit with its wooden sleeve and black front. I look for them on eBay now and then, but they're usually really tatty and people want too much money for them, so I pass on them. But this one came up dirt cheap price, and it actually looked in surprisingly good condition, so I bought it. It was a spares and repairs one, but that's not a problem. So this is a look at it. Right, this is the amplifier with the top removed. We've got a couple of this is the basis in two halves, so that's one channel and this is the other channel. So the output stage is two of these germanium transistors. They're AD161 and a 162. This is a driver transistor and this is a preamp transistor, and the same is repeated on the other side. So I powered it up and it was dead, so I then checked these capacitors. There's a whole load of capacitors on it. They were all invariably, most of them just didn't work. I took the germanium transistors out of this side and just replaced them with some silicon ones just to see what that did, because I wasn't entirely convinced about the these transistors. They all tested okay on the meter. Still no output. I had to then sketch out the circuit diagram to try and work out what on earth was going on. So this is there's no circuits on the internet for this thing, so this is a drawing I sketched out. There's not much to it really. The reason it didn't work was because I hadn't actually connected a loudspeaker up to it, because part of this circuitry kind of relies on this 8 ohm loudspeaker here. So got my dummy load resistors out and connected them across the speaker terminal, switched it on, and it burst into life. So yeah, that was interesting. But also what I suspected was that these silicon transistors on this side were going to cause a lot of crossover distortion, because the bases are just literally joined together. The NPM one, these plus 0.7 volts, and the PNP one, these minus 0.7 volts on the base to make them switch. So you're going to end up with a bit of a dead point where neither of them are switched on. Whereby these ones, these germanium ones, need 0.2 of volt to make them switch, so they seem to switch much better. Right, this is looking at the left and right output of the amplifier on the oscilloscope, and you can see on the top trace there's a bit of a nasty little kink in it. That's where that's coming from the silicon power transistors, and the little sort of glitch in it is the point where neither transistor is actually switched on, so they're both off, so the audio kind of gets cut off at that point. But by the lower trace is coming off the old germanium transistors and is working fine. So I've now put the original germanium transistors in this amp, so both left and right amplifier channels should be the same. The on and off switch on this amp is part of the volume control, and as you can see, we've now got two nice sine waves coming off both channels. When you it works out at about 2.5 watts just at the point where it starts to clip, which is a bit lower than the spec, which should be 8 watts, but we never really know how that spec's calculated in the first place. Okay, I've put it all back together again. I hooked it up to a laptop playing what should be royalty free music. So it all works pretty good. There's some interesting info about the way Amstrad got Comet to buy a load of these amplifiers on the Amstrad website, which is worth a read if you're interested. Thank you for watching this video, and please subscribe to be alerted to any new videos I upload.